Hi, my name's Dr. Damon Britton, and I'm a postdoc researcher at the Institute for Marine and Antarctic Studies at the University of Tasmania. And this is the first in a series of videos where I'm going to talk about a field study we're running looking at this idea of coastal liming. So this is a form of ocean alkalinity enhancement, or OAE. So what is coastal liming? Coastal liming involves the purposeful addition of calcium carbonate or limestone into vegetated coastal sediments that have high organic content. So these are things like seagrass, mangrove, salt marshes, these areas. So when the primary producers in these systems photosynthesize, they take up CO2 and convert it to organic matter. And some of this organic matter over time accumulates in the sediments. And this is broken down by bacteria which release CO2 and lower the pH of the pore water. So limestone doesn't normally dissolve in normal seawater, but when the pH is lower, it promotes dissolution. And when this limestone dilutes in this lower pH pore water, it releases alkalinity, converts the CO2 into bicarbonate and carbonate, and then this enables more CO2 to be stored in the pore water and overall increase the total DRC in this pore water. So there are two main implementation pathways to dissolve calcium carbonate in vegetated coastal sediments. The first one is when you start with an unvegetated coastal sediment that has legacy calcium carbonate, and then you restore the vegetation, whether it's seagrass or mangroves, and thereby provide the fuel for the bacteria to release CO2 and dissolve the calcium carbonate. So this is also known as blue carbon OAE. And the other way, which is the way we're looking in our study, is when you start with a fuel source but no calcium carbonate to dissolve in the sediments, so you supplement your sediments with additional calcium carbonate or limestone. And this is what we're referring to as coastal liming. So the design of the study involves 6 plots of 12 by 12 metres and in around 2 to 3 metres water depth in a seagrass bed in southeast Tasmania. And 3 of these plots are treated with limestone or agricultural lime that we sourced locally from Mole Creek in Tasmania, and then the other 3 are left as untreated control. The limestone plots were treated with 2 kilograms per square metre, and we do this by hand on diving, and this allows us to accurately place a homogeneous amount of limestone where we want it within the experimental plots. And the duration of the study is going to last for 1 year, and we're going to monitor whether or not it dissolves and how much alkalinity is released over this year. And then my wonderful colleague, Marianne Pelletier, is going to talk about the ecological assessment that she's going to be doing as part of this study. There's a really big team involved in this research study, and you'll get to meet many of these over the course of this series of videos.
Hi, my name is Marianne Pelletier, and I'm a PhD student here at the University of Tasmania. My portion of the study will be to look at the environmental impacts of coastal liming. I'll be looking at the seagrass characteristics, so growth, density, biomass, and primary production over the course of the year. I'll also be looking at different communities. This will include the infauna communities below the sediment and the epifauna communities that live within the seagrass canopy. This will also include fish and invertebrates that live just above the benthos in the seagrass.